we are doing Scholarship Calculus 2023, question 1C. Line L intersects the parabola y squared equals kx at the point A and B, such that OA is perpendicular to OB, as shown. Show that line L crosses the x-axis at k, 0. Now, this theta is done by one of my students. Forget it. There is only perpendicular sign, right? And I think I wrote k over there. So we have to prove that one is k, right? So let's start with, this is not that hard question, but I found it's a bit tedious. And on the way, you may make some mistakes. So you should be very cautious handling with this kind of question. So A, say x value is a, small a, I mean. So y value is what? So what is it? Y is plus minus square root of kx. Hence, when I plug a, that must be positive square root of ka or ak. K is better. Ka. Now, b, same way, if I say b is x value, then y value must be minus, see, minus side. So minus square root of kb, right? Right, so first of all, let me build the system satisfying this such that OA is perpendicular to OB. You know, when two lines are perpendicular, what does that mean? The gradient of, the product of two gradients is -1, right? So say m1 times m2 must be -1. So we have to use that in this. So how would you make a gradient easy? So OA is what? So say gradient of OA. So change in y, square root of ka minus 0 over a minus 0. So a. Gradient of OB is minus square root of KB over B, isn't it? When I multiply this, so square root of KA over A times minus KB over B must be -1, isn't it? So what does that mean? So KK, square root of KK becomes just K, and square root of AB over AB is 1, isn't it? So what it means is I can change that AB to square root of AB, right? Square root of AB times square root of AB, I mean. So cancel out, equals 1, hence what? K is square root of AB, right? I believe this is very important. Now, so to find x-intercept, we have to find the equation of AB. So to do that, we have to start with y equals mx plus c, right? Find the gradient and the y-intercept. So the gradient is what? So say just that gradient is change in y, which is square root of ka plus square root of kb, isn't it? Over a minus b, right? Hold on. Now what? Yeah, so we just plug that in. So y equals square root of ka plus square root of kb over a minus b x plus c. Let's find out c. So because this line passing through a comma square root of ka, also this, but I think this these coordinates are easier. So square root of ka equals what? Square root of ka plus square root of kb over a minus b times by a plus c, isn't it? So because we have to make a c the subject, so I've got square root of ka minus square root of ka plus square root of kb. Oops. kb. I'm gonna say a here. Sorry. A over a minus b, isn't it? Right, I think we are getting there. So I complete the equation y equals square root of ka plus square root of kb over a minus bx plus square root of ka minus a times square root of ka ka plus square root of kb over a minus b, isn't it? So x-intercept means when y is 0, so I'm gonna plus, and then we find x. So what I have is a square root of ka plus square root of kb over a minus b minus square root of ka equals square root of ka plus square root of kb a minus b x, isn't it? Right, I see I have to combine them. So a minus b, a square root of ka plus square root of kb minus a minus b square root of ka, isn't it? Equals what? That. Right? Times by x. So obviously a minus b cancels out. So therefore x equals a square root of ka plus square root of kb minus I will write it square root of ka first, a minus b over square root of ka plus square root of kb, isn't it? Now we have to cancel out. I see square root of k can factorize, right? So that way I can cancel out all square root of k. I hope you see that. Why am I okay? Let's try this. Okay, not good. No, never mind. I tried to change the color, but now so if I write this, oh good, perfect. So square root of k and square root of k can cancel out, right? So what left now is square root of a plus square root of b, right? And then at the top, a square root of a plus square root of b minus square root of a times a minus b, isn't it? And did you know a minus b means square root of a plus square root of b times square root of a minus square root of b, isn't it? A squared minus b squared is a plus b times a minus b. So, well, a plus square root of a plus square root of b is common vector. So what left is, I don't have to. So it's good that we, get rid of denominator. So what left is a minus square root of a, and square root of a minus square root of b, isn't it? Right? So if I expand a minus square root of ab, beautiful. So a is gone. Oh, sorry, it's plus, isn't it? Q. So square root of ab. Do you remember at the beginning I said where? Oh, here. K equals square root of ab. So therefore that is k. Right. It was very lengthy, but yeah, it was good. Good. We proved it. Well done, and I will see you next time. Alright, 안녕.